Hello everyone, I'm Lukasz Migda. Thank you for joining to our webinar. I'm country manager for Baltic countries, Central and East Europe, and today I will present you our Satsurv software for surveying. So let's start, and we will start from short briefing. SatLab Geosolutions. Our company is a Swedish-based satellite positioning solution company. So we comes from Sweden, and the company was founded, was created by a group of pioneering engineers with more than 40 years of experience in our industry of GNSS, GPS, and other devices for measurement. For us, the most important is using Swedish science and technology to bring for you, all of you, more innovation and unique solution for hardware, software, and other integrated solution to make your life easier and better. About SatLab on the world, our main office is Gothenburg in Sweden. We have also office in Warsaw in Poland, where I'm here. We have in Czech Republic, Turkey, USA, China, Hong Kong, Singapore, and Dubai. And we are also in with our dealers network in more than 50 countries. For the start, before we will go to the our software presentation, take a look on some details about interface. We make some tests, and our users mostly use detailed survey interface is 67%, and also mostly use stake point interface. So we mainly focus on develop these parts to make it more easier and more useful. Quick brief about our receivers. We have portfolio of full range of receivers, SS600, 700, 800, and 900, and they are powered by OEM 7 GNSS engine, support full constellation, and some of them use tilt sensor. Once more about our GNSS is our device, this SatLab SFC. This is the unique device because we can use it as a sensor, as a PK device, as a hand device for many applications. It support full constellation, GPS, GLONASS, Beidou, and Galileo, and with correction has modem, has Bluetooth, NFS, and also BLA Bluetooth. So this device we can use for many different applications. You can use any screen, you can use any software you want. You can use everything you will find on the market. So we can use this SFC for surveying and geodesy. We can use for high accuracy GIS, for web-based solution, CAD-based, precision farming, hydrography, geophysics, aeronautics, utilities, UAV base station. But there is something unique we can use also for VR and AR solution. As we see on the screen, we see here some virtual vectors in real time on real solution. Also, we support and we will provide many different controllers and computers, so everyone can choose the platform and what is the best for him. So we have rugged tablets, we have rugged computers, we have Android controllers, we have Windows, also Windows mobile controllers. So wherever you want, we provide to you. About our presentation today, we will have three parts. First of all will be some tips of project management, some new improvement. For the second part, we'll show you new features in surveying and staking out of interface. And part 3, some introduction of different tips and survey modes in our receivers. Let's start from first tips for project management. So we'll have here, we'll talk about project, we'll talk about COGO interface. We'll focus on multiple ways to others write projects for data management, the grid files, because we improve some new issues there. COGO interface, coordinate, transfer, and async compute. Let's start from project search. I will show you some short video here. We can search product by name. Let's see, just only one letter, and you see all the list. And also we can search multiple ways. Sort by name, by time, by size. If you have many different projects, it's much more easier to find by sorting. Raw data path outputting. We have here possibility to import raw data from other job to one job. If you work on the same place and instead of create every day new job, you can just merge everything in one job, as you see on the short video how to do this. And everything you have here inside in one job, in one raw data. Just choose directory, raw data file, and we have everything in one place. Calibration correction management. This is something very useful because sometimes we set up a base station, but we don't have a node point on the base station, so we don't have a created position of our base. We have option which allow to us to compute corrected base station by using our rover and measure the node point. Let's see the short video. It will show how it looks. We have base station, no point, and we have offset between correction of right position. Let's see how it calibrated. Very fast, we choose the points. The points are compute, are calibrated. And we have corrected base calibrated. Sometimes also we measure in wrong place. We measure in wrong points. So we have also framework calibration. This one allowed us to everything calculate to concrete and it's allowed to calibrate to concrete points if we make some different and wrong measurements. We also improve some Google Earth HTML files. So everything we create everything we measure. We can make a photo, and we can also very easily display on the Google Earth Pro. Let's see the video how we can do this. We import all coordinates or points. We choose control points. It's imported. And now we can display it on the Google Earth. We can see also our photo we made on this place. We also improved the grid files management. Grid files from all available from Trimble.com, so we can now work on all geoid models available on Trimble.com. But if you have any grid files you need to use, just contact with us. We will provide for you, and everything will be done. So we see here the list of our grid files. COGO interface and coordinate transfer. We can easily coordinate transfer coordinates from BLH to NEZ. So let's see how we can do this. We have a short video to show you how it's possible. We choose BLH, we choose NEZ, and import data. It's imported. That's all. Very fast, very quick, very easy. COGO interface. We have sometimes difference if we work with GPS and total station. We have some different grids. So we provide some option who allow to combine scale factor 3D or 2D distance, because sometimes the coordinates from total station and from GPS are different. So we see on the photo the distortion between the grid distance and the ground distance, and our combined scale factor. So we can very easily calibrate to make a measurement from GPS total station equal. Let's see how to do this. Short video. Coordinate points. We choose the control point. We see the coordinates. Just click compute. And we have result and difference between grid and ground distance. Now a little break, time for poll. So we back to Cassie. Cassie, your turn. Okay, we see 25% people tell map calibration, 50% coordinate calibration, and 25% receiver calibration. So the framework calibration is exactly coordinate calibration, 50% of attendance say correctly. Let's back to our part 2. We start with the new features in surveying and staking out interface. It's something new improvements. We'll see now device check, satellite solution, and how to check our device before work. Quick codes, how to set up quick codes, preparation before start of measurement, and also the unique feature AR stakeout. Let's start from the satellite solution, and we can see exactly what kind of satellites we have. On the screen, we see all constellation. Also, we can see the signal strength, and we see whole details about our satellites. Which one is used, which one is tracking. Device check. This is good option before we start to measure. We can check everything if our device is ready to work. Just push the start check and everything will be done automatically. Let's go to the quick codes. We can set up 81 types of the codes. These codes can be used by physical buttons on the controllers. So it's much more easier and faster to measure with our quick codes. Let's see short video will show you how to create the quick codes and how to set up on buttons. For example, we create description building. So we measure building and we want to use code 1, button 1. We can set up style, color. We can use as a point. And success we have made. Next code, we make a road, mark as point 2, color, and we have set up. And we see on the screen on one is building, on second is road, and we have measure. We can measure with by codes very quickly and very fast. We can use as well WMS. We have many available. We can also use our local WMS background by just input the link. Let's see how it to do. Here we have the link to map server. You can use username and password if it's needed. Connecting to server. And we have background now. Very fast, very easy, very useful in the field. Before we start work, we can prepare our background, our layers. We have cut interface in our new version. We have more vector elements. You can see on the screen how much new elements we have. We support the DXF files, DWG as well, so we can choose what we want to work. There are layers. And let's see how to use background. We choose the file very fast imported, and we see now very good accurate and in high resolution DXF file. And we see here what kind of vector elements we can use in our software. AR stakeout. This is something unique feature. This is something very interesting for all of us because we can use our camera and in real-time stakeout points. So we see on the middle screen how it looks, and let me show you on video how it looks in real time. We choose the point, we have button AR, and now we see in which direction we need to go. We have compass, we have arrow show to our direction, and we go to the point. When we go to the point, we have very accurate 3D bubble, and we see how detailed we can stake out point. Closer, closer, and we are on the point. We can also use voice commands. We have assistant who will remind us about direction. Is also very useful. We can also log direction from the controller. We see here the button. This button can allow us to log the direction, log the map, and the whole map will move with us always in direction we go. We also have active cat background for stakeout. So if we have a vector file, we can use the vectors there for stakeout. We can choose the point, we can choose select node point, we can select tangent point, perpendicular point, and intersection. So let's see to the more details about it. Point select. Let's see how we can choose the point, how we can select point for our stakeout. We choose the button point. Let's mark point. We have a red dot here. We have coordinates of this point, and we can go to stakeout. We logged the direction here, so our map moving with us. The green arrow, big arrow, show us our direction, and here we have also AR button if we want to use AR option. Line select. Let's see how to stake line. We choose the button of the line here was. We have line, first and last point, and we see our line. When we start moving, the arrow will show us the direction we need to go, and map also is locked, so map is moving with us. More useful option for stakeout, intersection point selection. Take a look on video how to choose the intersection. We need to mark first line, second line, and now we have point intersected. Tangent point is used on the arc. We choose the curve, and we have marked point successful. Perpendicular point selection. We have two lines, but we want to measure point crossing these lines. We choose select point, so select lines, and we have point on the crossing. Here we can stake out. Now time for second break, second poll. Enjoy. Cassie, your turn. Okay, we finished this one. So let's begin to the part 3. So we'll show you now the different of tilt survey modes in SatLab receivers. So we have here 2 modes and 2 models. Now we have SL700, which use the slope method to 0, and we have SL900, which use the normal slope and corner slope. For SL700, there is input the advanced algorithm by shaking the device by following the guide on the screen. We can measure every point and we can achieve the accuracy 5 centimeter and tilt degree is 0 to 30. And SL900, we have acceleration transducer, orientation sensor, and magnetic sensor. So we need to calibrate before surveying, and we can achieve accuracy on 3-4 centimeters. Tilt degrees as well as 0 to 30. So let's see how looks the slope method to 0 in SL700. We see on the screen that we need to shake device, shake pole after we reach the 100% and we have measure points. And in SL900, we have measure into direction to achieve the point tilt in tilt survey. For the end of our presentation, few words about how to get our Satsurv. Soon you can official version download from Google Play Store. Can be also download from the link below, or you can just ask us, send to email or contact with our support. We'll provide you the installation file. From my side, this is everything. Thank you very much for attending. Thank you for this meeting, for our first webinar in this month. And I hope you enjoy, and please feel free to contact with us. We'll help you and we'll guide you if you want to know something more. If you have questions, of course, you can write it to us. We'll support you. Thank you very much and see you next time.